Today we're looking at finding both the x and y intercepts given an equation. Now this equation is given to me in vertex form, so this is a common question seen in grade 11 pre-calculus, as well as in grade 12 as also. The number one step when looking for a y-intercept for any graph is setting the x value in the graph equal to 0. So I rewrite my graph. I replace that x with 0. And basically it becomes an order of operation or bed mass question. We do what's in the brackets first. 3 plus 0 is 3. We then have to square the 3 to get 9. Negative 2 times 9 is negative 18, plus 12, and we end up with our y-intercept, which is the point where this graph crosses the y-axis. The x-intercepts, always a little more difficult, again, requires a very important first step, which is, in this case, setting the y equal to 0 and solving for x. So we want to get x by itself, so we're left with an x is equal to solution. And in order to do this, it's like solving an equation for x. So what we're doing is we're almost moving in the opposite direction of bed mass. We deal with getting rid of my pluses and minuses first. So anything outside the brackets, I would move to the opposite side. So positive 12 becomes negative 12 when we cross the equal to sign. This leaves me with negative 2 bracket x plus 3 squared on the right. The next thing, order of operations says that if I'm coming from the bottom up, I'm looking for any division or multiplication. And sure enough, we have division, right, or multiplication, negative 2 times the brackets. So we're going to get rid of that by the inverse operation, division by negative 2. And of course, like any equation, what we do on one side, we have to do on the other. So we end up with 6 on the left and x plus 3 all squared on the right. Second last, we're now at our exponent position on bed mass, and to get rid of that square outside of the brackets, we're going to use a square root. And once again, what we do on the left, on the right side, we have to do on the left. Now, the square and the square root are inverse operations. They're going to cancel each other out, leaving me with x plus 3 on the right side, and the square root of 6 on the left, which we need to write as plus or minus. Finally, I have to get rid of my 3, which was the bracket section. I've removed the brackets. I don't need them there anymore. But I can simply just take the 3 across to the other side and change the sign of it when I move it, leaving me with my final solution. And because the root of 6 is an irrational number, we can leave our x-intercepts in this form. If I have a perfect square inside that root, such as the root of 4, we can evaluate that, get 2, and work out both points. But in this case, we would leave our answer as that.